live in the age of abundance. I mean, I want you to just think about that for a second.
Oh, yeah. It really is unprecedented.
Right. You have more information at your fingertips right now than, well, literally any human being in the history of our species.
It's almost overwhelming.
Exactly. Like, if you want to know what a celebrity had for breakfast in Milan, or you want to watch a live stream of a protest in a city you've never even visited.
Or read, 14 different hot takes on a political scandal before your coffee even gets cold.
Yes, you absolutely can. We are completely drowning in human narrative. But here is the profound irony of the feed you're probably doom scrolling right now.
And we all do it.
We do. But for all that infinite, abundant information, we have actually never been more disconnected from the actual physical reality of the planet we're standing on.
That is such a crucial point.
Like, you can read 1,000 tweets about a storm, but your phone can't actually tell you the exact moisture content of the soil beneath your feet.
It is a wild paradox, honestly. I mean, we've built these incredibly sophisticated, instantaneous global networks.
Right.
But we use them almost exclusively to exchange human opinions and cultural chatter.
Just endless talking.
Exactly. The physical Earth itself, the air quality, the microclimates, the actual structural realities of our environment is mostly locked out of that rapid-fire conversation.
Today, we are exploring a...
He isn't just throwing out a science fiction concept. He is laying out a specific mechanistic argument for why the future of our entire information ecosystem relies on this.
turning a social media platform into a physical mirror of the world.
Exactly.
So the mission for this deep dive is to extract the core of that argument. We're going to look under the hood at the actual physical mechanics.
The satellites, the ground sensors, the AI, all of it.
All the stuff that would make this planetary mirror function. And we're going to explore the author's philosophical claim, too.
Which is arguably the most important part.
Right. The idea that democratizing this environmental data is the most critical public utility of the coming decade.
Okay, let's unpack this. Because to understand the scale of what Bhagat is proposing, we actually have to start with astrophysics.
Wait, astrophysics?
Yeah, I know. But the central metaphor he uses is just brilliant. He asks us to look at the current state of X through the lens of ordinary matter versus dark matter.
Oh, I see. So in astrophysics, ordinary matter is like everything we interact with. It's the visible stuff.
Right, exactly.
The stars, the planets, the device you're listening to this deep dive on right now.
But in the context of the entire universe, all of that visible luminous matter only accounts for about 5% of the total mass and energy.
Wow. Only 5%.
Just 5%. The other 95% is dark matter.
And dark matter isn't just like invisible, right?
And that is a really common misconception. Dark matter is actually the foundational structural scaffolding of the universe.
It's the gravitational glue.
Yes. We can't see it, but its immense gravitational pull dictates how galaxies rotate, how star clusters form.
It dictates how the visible matter actually behaves.
Precisely. Without that 95% of invisible dark matter, the 5% of visible stars would literally fly apart into the void.
Okay, so Bhagat takes this physical reality of the cosmos and maps it directly onto the platform X.
He does.
So the visible 5%, the ordinary matter, that represents human tweets.
Right, the 280-character posts, the memes, the breaking news alerts, the eyewitness accounts.
It's what he calls the cultural heartbeat.
And what's fascinating here is that the author is careful not to dismiss that human layer.
Because it's still important, obviously.
Very important. Those voices are essential. They provide narrative, emotion, and context, things a machine simply cannot generate.
But he argues that if we're trying to measure planetary reality, relying on that 5% is a massive vulnerability.
Yes, because humans are fundamentally terrible sensors.
We really are incredibly flawed data collectors. I mean, think about it.
Oh, absolutely.
You sleep for a third of the day, effectively taking your little human sensor completely offline.
And even when you're awake, you have inherent cognitive biases.
Right. You might step outside and say, wow, it's freezing today, just because you forgot your coat.
Exactly. Not because the ambient temperature actually dropped in any statistically significant way.
Plus, you can only physically occupy one GPS coordinate at a time.
The geographic limitation is crucial. I mean, for every viral tweet showing a flooded street or a beautiful sunset,
There are millions of square miles of the planet where no one is posting anything at all.
nothing. Vast spectrums of physical reality like air toxicity or barometric pressure are completely invisible.
It is a map composed almost entirely of blank spaces, punctuated by these tiny, highly subjective pinpricks of light.
And even when the light is bright, it's noisy.
So noisy. Like, if a hurricane hits the coast, you might get 100,000 people tweeting about it simultaneously.
Which is great for situational awareness, sort of.
Yeah, but they're giving you 100,000 variations of "the wind sounds terrifying" or "my power went out."
Right. That is a vital human narrative,
Mhm.
but it is entirely useless if you're trying to calculate actual data.
Like the exact structural degradation of the power grid.
Or the precise millimeter-per-hour rise of the floodwaters in a specific zip code.
This is where the 95% comes in, the dark matter of X.
Yes.
Pagat argues that the true untapped value of the platform over the next decade will not come from human thumbs typing on glass.
No, it will come from the invisible majority.
The relentless, continuous explosion of objective data generated by the Internet of Things, or IoT.
We're talking about vast autonomous sensor networks here. Industrial monitors, drones, buoys in the ocean.
Virtual satellites.
Exactly. These machines don't need coffee breaks. They don't have political leanings.
They just sit there, second after second, generating petabytes of highly structured, mathematically precise data.
That is the dark data. And just like dark matter holds the galaxies together, Bogat's vision is that this invisible machine data will become the underlying structural framework.
The framework that holds the entire platform together.
Exactly. It grounds the chaos of the human conversation in a bed of absolute, measurable, physical reality.
Wait, hold on. I need to push back on this for a second.
Sure, go ahead.
If 95% of this platform's actual data volume becomes raw machine telemetry, doesn't that fundamentally destroy what made the app popular in the first place?
How do you mean?
I mean, if I open X because I want to see what people are saying about a basketball game or a presidential debate, and suddenly my feed is just an endless, unfiltered spreadsheet of barometric pressure readings and nitrogen dioxide levels from random sensors, I'm deleting the app.
Oh, absolutely.
You'd be drowning the visible stars in the dark matter.
That would be totally true if the data were presented raw, but that entirely misses the architectural design Bogat is actually proposing here.
Okay, clarify that for me.
The dark matter operates invisibly. You don't open the app to a giant spreadsheet.
Thank goodness.
Right. The human layer, the tweets, the videos, the cultural discourse, remains the interface. It remains what you see.
So the dark data simply provides the invisible context and validation underneath it.
Exactly.
So it's kind of like the data is the canvas and the human conversation is the paint.
That is a very apt way to put it, actually. The data informs the algorithms, verifies the human claims, and provides structural context.
It's a synthesis of human meaning and machine truth.
Not a replacement of one by the other.
Okay, conceptually, that makes total sense. But let's get into the actual engineering, because it is one thing to write a blog post saying a tech company should just, casually ingest the physical state of the entire Earth.
Oh, yeah. The logistics are mind-boggling.
Right. It is a completely different universe of difficulty to actually build that infrastructure. How is X supposed to collect a planetary web of physical data?
Well, Bogat proposes a two-pronged approach. He envisions a fusion of macro-level orbital assets and micro-level ground technology.
Okay, so let's start with the orbital stuff.
The first layer is the orbital backbone, and he points directly at an infrastructure that is already fully operational: Starlink.
Starlink. Okay, so most people know Starlink primarily as an internet service provider.
Right, a mega constellation of low Earth orbit satellites.
Providing low latency broadband, especially to places where running fiber optic cables is just physically impossible.
But the author suggests we are thinking way too small if we only view Starlink as a glorified internet router in the sky.
Interesting. So what else should it be doing?
He proposes equipping a dedicated subset of that massive orbital hardware along with the millions of ground terminals sitting on people's roofs, with an array of active and passive environmental sensors.
The list of metrics he wants to pull from orbit in this piece is staggering.
It's incredibly ambitious.
He's talking about high-resolution tracking of temperature, atmospheric pressure, wind vectors, global precipitation.
Even lightning strikes.
Yeah, and he even talks about tracking soil moisture from space, which honestly just sounds like magic to me.
It does sound like magic, doesn't it?
Like, how does a piece of metal flying through the vacuum of space know if the dirt in a Kansas cornfield is damp?
It really comes down to the physics of microwave radiometry.
Okay, you're going to have to break that down for me.
Sure. So everything on Earth naturally emits low levels of microwave radiation. Everything. But water, however, emits and reflects these microwaves very differently than dry soil does.
Is that because of the electrical properties of water?
Precisely. Water has a very high dielectric constant compared to dry dirt. So by putting a highly sensitive passive microwave radiometer on a satellite, specifically tuned to what's called the L-band frequency, the satellite can actually measure the natural microwave emissions coming off the Earth's surface.
And the intensity of that signal changes.
Yes. It changes depending on exactly how much water is mixed into the top few centimeters of the soil.
Wow. So the satellite is literally listening to the electromagnetic hum of the mud.
It is. And currently, soil moisture data is often gathered through incredibly slow, expensive means.
Like sending people out to physically sample dirt.
Yeah, or relying on localized farm sensors that might not cover a wide area.
But if you integrate L-band radiometers into a web like Starlink,
You suddenly have a live, continuous planetary map of agricultural health. You could literally predict droughts weeks before crops start to physically wilt.
that is incredible. Okay, so that handles the macro level, the planetary scale.
Right.
But you can't measure the air quality on a specific street corner from low Earth orbit with any real precision, can you?
No, definitely not. And that brings us to the second prong of the architecture, the surface mesh.
Right, because to map the human environment, you need sensors down where humans actually breathe and move around.
Exactly. And Pagot's proposal for this is highly decentralized. He suggests utilizing vehicle fleets by introducing a simple magnetic hardware pod that attaches directly to cars.
The text describes these pods as containing highly affordable, miniaturized sensors.
Yeah, they would be tracking complex atmospheric telemetry.
They'd just focus on the immediate microenvironment, hyperlocal temperature, road conditions, and crucially, air quality.
Air quality is the massive blind spot in current urban planning.
It really is.
These car pods would track things like nitrogen dioxide, ozone, and PM 2.5.
PM 2.5, right. That's the microscopic particulate matter.
Yes, from vehicle exhaust, power plants, wildfires.
The stuff that is small enough to bypass your respiratory defenses and get directly into your bloodstream.
It's a massive public health crisis.
But our measurement of it is surprisingly primitive, isn't it? Most cities only have a handful of static air quality monitoring stations.
It's completely inadequate.
Like, you might be breathing toxic air on a busy intersection, but the city's official sensor in a park 3 miles away says everything is totally fine.
Exactly. So by equipping cars with these magnetic pods, Fagot envisions turning millions of everyday commuters into a distributed, mobile observation network.
It's like injecting millions of microscopic white blood cells into the veins of a city.
That's a great visual.
As people drive to work, drop their kids off at school, go to the grocery store, their cars are constantly sniffing the air.
Taking the city's temperature, checking its oxygen levels, and beaming that data back to the central nervous system.
But why would a driver agree to stick a tracking pod on their car in the first place?
Well, Fagot outlines several incentive structures for this. Some might do it purely for civic contribution, knowing they are helping map local pollution.
Sure, some people are altruistic like that.
Right. The system would also obviously require ironclad, privacy-protected data sharing where the user is completely anonymized.
That's essential.
And there could be microtransactions, small financial or platform-based rewards for providing continuous data.
Okay, I have to pause you there because the logistics of this sound like an absolute nightmare.
Oh, I'm sure you have thoughts.
Let's just think about the physical reality of a car for a second.
Okay.
You stick a highly sensitive temperature and air quality sensor on a metal box that is propelled by a literal combustion engine or a massive heat-generating battery.
Right.
The car parks, idling in traffic, surrounded by hot exhaust. Then it drives through a freezing puddle.
Yep.
Then it parks in a heated underground garage for 4 hours. I mean, the ambient heat of the car alone is going to completely warp the temperature reading.
It is a very messy environment.
If this pod is sending data back to X, it's just going to be generating petabytes of absolute garbage data.
You've identified the exact reason why a standalone single-sensor approach fails completely.
Okay, so how does it work then?
If you look at the data from one car, or even 100 cars, it is hopelessly compromised by the exact variables you just mentioned.
Right.
But Fagot's architecture doesn't rely on individual accuracy. It relies on the law of large numbers and sensor fusion.
Sensor fusion.
Yes.
Yeah.
The secret sauce here is the immense volume of the crowd.
Wait, so millions of bad readings somehow mathematically create a good reading?
Through the application of advanced artificial intelligence, yes.
Oh, I see.
When you have terabytes of raw data flowing in every single second, You use AI to run continuous outlier rejection and Bayesian probability models.
Okay, break that down for the listener.
So the AI knows what the macro level temperature should be from the Starlink satellite above, right?
Right, it has the baseline.
Then it cross-references that baseline with 10,000 cars in a single zip code simultaneously.
Oh, wow. Okay, I get it now. If one car is reporting an ambient temperature of 85 degrees, but the satellite says it's 60,
Exactly.
and the 500 other cars driving on that exact same avenue are reporting 61 degrees.
The AI instantly recognizes that the first car is parked in a heated garage or sitting directly behind a diesel exhaust pipe.
And it just tosses that reading out.
It mathematically filters out that noisy data point in real time. The individual sensors can be cheap and flawed because the AI is doing the massive heavy lifting of cleaning, fusing, and correcting the data on the back end.
When you lay it out like that, it's really impossible to ignore the overarching footprint of Elon Musk's portfolio of companies in this vision.
It's almost startling how neatly all the pieces fit together.
It really is. You have SpaceX and Starlink already building the orbital backbone and the global connectivity mesh.
Right.
You have Tesla representing millions of rolling computers with advanced telemetry and battery architecture already on the roads.
And you have xAI building the neural networks capable of processing petabytes of noisy data.
And finally, you have X itself serving as the global distribution and user interface platform.
Vagat is essentially arguing that this planetary nervous system isn't some far-off pipe dream requiring unimaginable new technology.
The pieces are already on the board.
Exactly. The specialized verticals already exist. The hardware is already deployed or in active development.
So it's just about integration.
The vision simply requires connecting these isolated verticals into a unified horizontal mesh. No municipal government or single-purpose weather startup could ever dream of rivaling a multi-layered, opt-in hardware network of this scale.
Okay, so let's put ourselves in the shoes of the listener right now.
Sure.
Let's assume this colossal engineering feat is actually achieved.
The hardware is all connected?
Right. The satellites are up there measuring the L-band microwave emissions of the soil. The millions of little car pods are sniffing for PM 2.5 on the streets.
And the AI is flawlessly filtering out all the noise.
When I open the X app on my phone, what do I actually see? How does all this invisible dark matter actually manifest in my daily life?
The author describes a complete paradigm shift in the user interface. Imagine a weather and climate dashboard built natively into the platform, but one that operates at a level of resolution we currently reserve for military or advanced scientific applications.
He calls it Google Earth reimagined as a living, breathing dashboard.
Yeah, and that distinction is paramount. Traditional maps, like Google Earth, Apple Maps, they're incredible, but they're static resources.
Yeah, they offer stunning detail, but you are basically looking at a photograph taken months or sometimes years ago.
Exactly. A static map shows you the geography, but a living map shows you the physiology.
It's a map with a pulse.
I love that. Yes, a map with a pulse. When you look at this dashboard, you aren't just seeing current conditions. The AI is integrating what's called ensemble model projections.
Let's break that down for a second, because ensemble models is a term that gets thrown around in meteorology a lot.
It does.
Basically, instead of running one single supercomputer simulation to guess the weather,
Which is how a lot of basic forecasting works.
right, the AI instead runs dozens or even hundreds of simulations simultaneously.
Yes, and in each of those simulations, the AI tweaks the starting variables just slightly.
Like what?
Like a fraction of a degree in temperature here, a tiny microscopic shift in wind speed there.
Because the atmosphere is chaotic, so those tiny tweaks result in vastly different outcomes.
Exactly. By looking at the ensemble, the entire group of simulations all at once, the AI can give you a highly accurate probability curve.
So it can say, 80% of our models show the storm hitting this exact neighborhood at 4:5 p.m.
Right. And because the data is coming in live from the satellites in the cars, those models update continuously, second by second.
And the text emphasizes that this dashboard would be entirely zoomable, too.
Yes, from the macro to the micro.
Like you could pinch your screen out to view macro-level phenomena like tracking the moisture content of an atmospheric river sweeping across the Pacific Ocean.
And then zoom seamlessly down to your specific street to see the live PM 2.5 pollution index on your block. Imagine the sheer utility of that during a spontaneous crisis. The author highlights fast-moving events like wildfires as a prime example.
Right now, if a wildfire breaks out in California, the information ecosystem is agonizingly slow.
It is dangerously slow.
You smell smoke, you check social media to see if anyone knows what's happening.
Maybe you wait for a local news helicopter to get in the air.
Or you check a government forestry website that, only updates every 6 hours.
But if we connect this to the bigger picture,
Mm.
in the reality Bhagat proposes, that timeline shrinks from hours to literally seconds.
How exactly?
Well, the AI detects an anomaly instantly, a sudden micro-local spike in temperature and a simultaneous drop in humidity reported by the car pods driving through a specific canyon.
And it cross-references that?
Instantly cross-referenced with a thermal infrared anomaly detected by a Starlink satellite passing overhead.
Boom.
The platform automatically generates an alert, drawing a precise, real-time boundary line of the fire directly on the map.
And that map updates minute by minute as the car sensors actually detect the advancing wall of heat and smoke.
It fundamentally changes risk management. It saves lives.
And it extends beyond just extreme weather into daily urban life, too. The text details how this living map completely transforms our understanding of traffic and mobility.
Right. By using anonymized, aggregated data on how pedestrians and vehicles are physically flowing through a city, the platform maps urban congestion dynamically.
Contrast this with how urban planners have to operate today.
Oh, it's night and day.
A city council deciding where to build a new subway line or a bike path is often relying on municipal census data from 5 years ago.
Or they hire a fancy consultancy firm to do a highly expensive 2-week manual traffic study.
Which is just a slow, lagging indicator of how a city actually breathes.
But with the living dashboard, public transit planning becomes entirely empirical. Planners can watch the exact real-time movement of millions of people.
So the AI can highlight an underserved transit corridor where vehicle speeds routinely drop to 3 miles an hour every Tuesday at 4 p.m.
And it can automatically simulate the impact of adding a dedicated bus lane right there. It replaces theoretical modeling with objective reality.
And, again, the AI acts as the vital translator here.
Always. It takes these unfathomably complex data sets, the raw traffic telemetry, the L-band microwave readings, the ensemble models,
and translates them into intuitive, actionable insights for the user.
The text gives a fantastic example of a personalized AI alert. It says, air quality declining rapidly in your area-sensitive groups should limit outdoor activity.
It doesn't just hand you a raw graph of particulate matter and expect you to be a trained meteorologist.
Right. It interprets the planetary data through the lens of your specific location and your personal health needs.
Okay, this all brings us to a massive foundational question regarding the entire premise.
Let's hear it.
If we accept that this hardware network can be built and the AI can process it and the dashboard would be revolutionary,
Yes.
why does this have to happen on X?
The platform question.
Yeah. Why tether the most advanced environmental monitoring system in human history to a social media platform known for political arguments and memes?
It's a fair question.
Why wouldn't SpaceX or Tesla just launch a dedicated, standalone scientific app, call it Earthwatch or something?
That is the pivotal architectural choice in Phagat's essay, actually. Building a standalone app ignores the massive hurdle of distribution and context.
Distribution is always the hardest part.
Exactly. X already possesses two massive assets that a purely scientific app would take decades to build from scratch.
Which are?
Instantaneous global distribution to hundreds of millions of daily active users, and a pre-existing framework for narrative and community verification.
So the author makes a compelling argument that the true magic happens in the cross-validation.
Yes.
The fusion of the machine and the human.
The machine provides the objective ground truth and the massive planetary scale. The human provides the subjective experience and the narrative meaning.
Because a machine can tell you a statistic, but a human tells you why that statistic actually matters.
The text outlines a perfect scenario to illustrate this.
Here's where it gets really interesting.
Imagine the invisible sensor grid, the car pods, and the satellites objectively registers that the temperature in a specific zip code in Arizona has hit 95 degrees Fahrenheit.
Okay.
And it simultaneously detects rapidly rising PM 2.5 particulate levels.
That is the machine's truth.
Right. It is mathematically precise, rigorously verified by AI outlier rejection.
But it is entirely devoid of emotional resonance or local context.
It is literally just a row of numbers in a database.
But simultaneously, on the human layer of X, a user in that exact same Arizona zip code posts a tweet.
Right.
They say, it's 95 degrees out here and the air smells like burning plastic. My kids are coughing.
That is the synthesis. The platform becomes simultaneously social, scientific, and operational all at once.
The human's subjective emotional experience is instantly validated by the objective sensor data hovering invisibly right beneath the tweet.
And conversely, the raw, cold sensor data is given immediate, visceral human context.
You don't just see a rising line on a graph. You see a mother genuinely concerned about her children's lungs, backed by undeniable atmospheric proof.
It creates a closed-loop system of reality. Fagat describes this evolution as serving a deeper, almost philosophical mission for the platform.
He calls it maximum truth-seeking through maximum transparency.
By taking our human debates, our cultural narratives, and our political arguments, and forcing them to sit directly on top of an immediate, shared, measurable, physical reality.
It profoundly alters the nature of public discourse. I have to admit, though, I am struggling to see how human nature doesn't just instantly corrupt this.
You're worried about the human element.
Yes. You put a temperature gauge on a platform where people love to fight, and what happens? People on social media already deny basic, historically verified facts every day.
That is true.
If you roll out an environmental dashboard, won't half the users just start arguing over the calibration of the sensors?
Oh, inevitably.
They'll say the car pods in my neighborhood are biased, or the AI model that filters the data is rigged by the developers.
Yeah.
If people are ideologically motivated to deny a climate trend or an air quality reading, putting a thermometer in the app isn't going to stop them. Doesn't this just create a massive new vector for conspiracy theories?
The author actually does not gloss over the complexities of human trust and epistemic friction here.
Good, because it's a huge issue.
He anticipates exactly that response. If the data processing is hidden inside a corporate black box, the system will immediately succumb to allegations of bias.
So what is his structural solution to this?
Radical transparency.
How does that actually work in practice, though?
Through open protocols and open APIs.
Okay, an API.
Right. An application programming interface essentially allows external software to talk to the platform's internal database.
Right.
Fagat stresses that the raw data streams from the satellites and the car pods, as well as the AI models processing them, cannot be proprietary corporate secrets.
They have to be open.
They must be accessible to independent researchers, universities, and third-party watchdogs.
So let me make sure I'm getting this. If a viral post claims that the platform is intentionally faking a heat wave in Texas to push some political agenda,
Right, which would definitely happen.
an independent team of atmospheric scientists at MIT could literally plug into the open API.
Pull the exact same raw microwave radiometry and car pod telemetry.
Or run their own math.
And publicly verify whether the platform's dashboard is mathematically accurate.
Precisely. Trust isn't just demanded by the platform. It is cryptographically and scientifically provable by anyone with the technical literacy to actually check the work.
The goal is to make the physical state of the world undeniable, simply because the methodology of measuring it is entirely open to public scrutiny.
Which brings us to a really fascinating bridge. We are talking about open APIs, independent researchers, and proving truth.
This raises an important question.
It really does. Who actually owns the physical data of the Earth?
That's the million-dollar question.
If a private company builds the orbital mesh and the surface sensors, they technically own the petabytes of data flowing in.
But Fagat transitions from this heavy engineering framework into a profound moral argument here.
He claims that keeping this data siloed is societally destructive.
It is the ethical core of his entire thesis. Critical environmental data, the chemical composition of the air we breathe, the moisture of the soil that grows our food, the physical movement of our communities.
It's the lifeblood of our shared reality.
Yet historically, this incredibly important information has been treated as a restricted asset.
Think about where high-quality environmental data lives right now.
It's usually locked behind expensive academic paywalls.
Or hoarded by proprietary corporate consultancies who charge a fortune for it.
Or scattered across dozens of fragmented, notoriously clunky government portals that sometimes take days to update.
Fagat frames this as an absolute anachronism.
It really is. In an age where a viral dance video can reach 1 billion people in hours, the idea that a community shouldn't have instantaneous high-resolution access to their own local air toxicity or flood risk is fundamentally broken.
He argues that democratizing this planetary data, making it as free and accessible as a tweet, is the most critical public utility of our time.
And he breaks down the massive societal benefits of this democratization. And it scales up beautifully.
Right. It starts at the individual level. Informed citizens.
This is all about daily empowerment. Imagine you are deciding whether it's safe to take an elderly parent for a walk outside.
Instead of checking a generic weather app that just gives you a broad citywide average,
You check the living dashboard and see that a localized pocket of high PM 2.5 pollution is currently drifting down your specific avenue.
so you make a medical decision based on live, objective, hyper-local data.
That direct access strips away the reliance on filtered media summaries. The citizen is no longer passively waiting for the evening news to interpret the environment for them.
Then, that individual empowerment scales up to sophisticated governance.
Think about the mayors, the city planners, and the first responders.
Currently, local governments operate with massive blind spots. They really do.
They are managing 21st century cities using 20th century data collection methods.
But if a mayor and their emergency response teams have access to the exact same shared live operating picture as the citizens,
The efficiency of governance absolutely skyrockets.
Yeah.
Paramedics can route ambulances around microcongestion detected by the car pods in real time.
firefighters can deploy resources based on the live thermal boundaries of a blaze rather than relying on delayed radio reports from the ground.
And crucially, Bagat points out that a shared, objective baseline of evidence could actively reduce the vicious political polarization we see around climate and urban policy.
It forces the debate to evolve, doesn't it?
It does. You can passionately debate the economic merits of a carbon tax or the budget for a new transit hub. That is just politics.
But it becomes exceedingly difficult to debate the basic necessity of an air quality initiative when every voter in the city can literally open their phone
And watch a live, scientifically verified, AI-modeled cloud of nitrogen dioxide hanging directly over their children's elementary school.
The data removes the debate over the existence of the problem, allowing society to finally focus on debating the actual solution.
Finally, he argues that all of this leads to broader societal resilience. He touches on the concept of building an anti-fragile system.
Right. In network theory, an anti-fragile system doesn't just resist shocks. It actually gets stronger and smarter when exposed to stress.
Because the individual nodes adapt dynamically.
By placing this massive intelligence network directly in the public square, you tap into the collective genius of the crowd.
If you make the APIs open, a farmer in Nebraska can build a custom script to automate their irrigation based strictly on Starlink's soil moisture readings.
Or an independent software developer in Nairobi can use the open traffic flow data to build a perfectly optimized ride-sharing app for their specific local market.
You are taking the analytical tools and the situational awareness that were previously reserved exclusively for the Pentagon or the EPA or multi-billion-dollar hedge funds.
And you are just handing them to everyone.
It is a massive decentralization of power.
It completely redefines the relationship between the citizen and the environment.
We transition from being passive observers of the physical world, relying on institutions to tell us what is happening,
to being integrated, active participants in a continuous planetary feedback loop.
This has been an incredibly dense journey today.
We covered a lot of ground. We started by looking at a social media app famous for 280-character hot takes and doom scrolling.
We explore the invisible 95%, the dark matter of machine data.
We walked through the physics of satellites measuring soil moisture and the absolute logistical nightmare of millions of cars sniffing the air.
We examined how AI fuses all of that noise into a living, breathing dashboard of reality.
And why crossing that objective machine data with subjective human narrative could fundamentally upgrade public discourse.
Bagat's vision challenges us to view technology not as a digital escape from the physical world,
but as the ultimate mechanism for connecting us to it with unprecedented clarity. So what does this all mean? It makes you wonder how your own daily life would shift if you had the continuous objective pulse of the Earth sitting right in your pocket.
It really does.
But as we wrap up this deep dive, I want to leave you with one final lingering thought, something to mull over that builds on this entire architectural premise.
Let's hear it.
We've talked extensively about mapping the present moment flawlessly, but think about the nature of predictive AI.
Right.
If this system works, if this invisible dark matter of data successfully maps the entire physical reality of the Earth in real time, down to the exact movement of every crowd, the precise moisture of every crop, and the microclimate of every city street.
Where does it lead?
Exactly. How long until the neural networks processing all that data start accurately predicting not just tomorrow's weather or traffic, but the downstream human behaviors and historical events that those physical conditions inevitably create?
That is a fascinating and slightly terrifying question.
If a platform becomes a mathematically perfect real-time mirror of the present physical world, does it inevitably become a crystal ball for the future of human history?